In this video, the different electrical connection systems for the neutral and protective ground will be explained. In the different videos of the electrical panels, it has generated confusion in some of our friends due to the way in which the protective ground cable is connected with respect to the neutral. For example, in Peru and Argentina, the connection of the ground cable is different from that done in Chile or Mexico. And this difference is due to the type of connection system for the neutral and the masses in the electrical energy distributions. That is why this video will explain the different electrical distribution schemes that exist, what they are like. TT scheme, TN scheme, TNC, TNS, and IT scheme. The distribution schemes are established based on the ground connections of the distribution network or the power supply, on the one hand, and on the other hand, the masses of the metal enclosures of the loads of the receiving installation. In the electrotechnical regulations for low voltage, distribution diagrams are made using a letter code. The first letter indicates the type of ground connection on the power supply or transformer. And the second letter indicates the type of connection of the receiving masses. To understand better, you have more than likely seen a pole where cables reach and there is a three-phase transformer next to a box. That's what is represented in the diagram as the power supply. While the ground refers to the metal casings or casings that the devices have, which through the ground cable is taken to a terminal bar on the board and then taken to the physical ground well. In the distribution network there are almost always three-line or phase cables and a neutral cable, but since we mostly use a single-phase voltage, then only one line cable plus the neutral is used. In the distribution scheme, for the first letter that refers to the transformer or power supply, we use the letter T if there is a direct connection to ground from some point, which is usually from the neutral. And we use the letter I if the active parts of the installation are isolated from ground or if the impedance between these points is too high. So, we use T if there is a direct connection to ground, and the letter I if there is no connection to ground or because the impedance is very high, which is assumed as if there were no connection. For the second letter, which refers to the metal casings or casings of the equipment, which in this case are called masses, we use the letter T if there is a direct connection to ground from the metal masses or enclosures. We use the letter N if there is a connection from the grounds to the neutral. Of the latter, there are two more combinations which we will see in the course of the video. Let's see the TT distribution scheme. The TT scheme has one point on the power supply, usually the neutral or compensator, connected directly to ground. The masses or metal casings of the appliances in the receiving facility are also connected to a ground connection separate from the power supply ground connection. In this scheme, the phase ground or phase ground fault currents may have values lower than the short circuit values, but they may be sufficient to cause the appearance of dangerous voltages. That is why, for this type of system, thermomagnetic protections are required that detect faults due to overload or short circuit, and differential protections that detect current leaks greater than the assigned value. The current loop will circulate between the phase and the neutral. If there are small leakage currents, they will go to ground, so they would return through the ground to the power supply. If the leakage current exceeds 30 milliamps, then the differential switch trips and disconnects the entire circuit. On this channel we have seen how to wire this board which is used in Peru and Argentina. The connection of these electrical panels is based on the TT scheme. You may have noticed that on the poles where there is a transformer, there is also a cable that goes to ground and a notice that says, "Danger, well to ground." This tells us that the connection on the transformer is type T. Connection diagram TN. Three types of TN schemes are distinguished according to the relative arrangement of the neutral conductor and the protective conductor. TNC scheme, in which the neutral and protective earth functions are combined in a single conductor throughout the scheme. TNS scheme, in which the neutral conductor represented with the letter N and the protection conductor represented with the letters PE are different throughout the diagram. In this type of scheme, there is thermomagnetic protection against overload or short-circuit faults, but if said protection does not have the speed or response capacity to separate a fault, then it is necessary to use differential protection. TNCS scheme, in which the neutral and protection functions are combined in a single conductor in one part of the scheme. This distribution scheme is also used in many countries, for example, in Chile. Shown here is the panel, where the ground wire connection is connected to the neutral. Of course, here a physical ground is used before the board, which would make one think that we are dealing with a TT-type connection scheme, but this is not the case, since the neutral is linked to the ground cable. Then the equivalent scheme would be like the one shown. Grounding close to the masses is called neutralization or grounding of the neutral and serves to keep the neutral at 0 volts. The same scheme is also used in Mexico, the United States, Ecuador, Colombia, etc. Here you can see a small difference in terms of the grounding of the neutral cable since it is separated by different spikes or javelins, but these are connected to each other through a cable. The difference is that in these countries they use 2 active lines, but they are not out of phase. In another video I will explain this topic in more detail. Connection diagram IT. In IT schemes, the first letter, I, indicates that all active conductors are separated from ground, that is, there is no direct connection to ground in the power supply or there is a very high impedance between these points, while the second, the letter, T, indicates that the masses or metal casings of the devices in the receiving facility are connected to a ground connection. This means that, in the event of an insulation fault, only a small fault current can flow, mainly caused by the bypass capacity of the network. Under normal operating conditions, earth leakage currents will be minimal given the impossibility of returning the power supply to the transformer. This type of scheme is generally used in hospital operating rooms and emergency rooms, since there is little danger of electric shock to people. If you want more videos related to this topic, here at the end and in the description. See you later. Hasta luego.